This is the one I just turned in the little lathe. And if you put the m.e.k on it, it is 1.061, which is the 1,000th oversized that I needed for the hole. But I will give you a tip. When you're turning this down, take it out of the lathe, let it cool down, then put the micrometer on it. Make sure it's the correct size, because it will be, if you put the m.e.k on it while it's hot, trying to turn it hot, then when it gets cold, it'll be undersized. So let this cool down on your final sizing. To remove a bushing is as such. Let's remove this one right here. What I've done is I built a set of tools some time ago to do this with. And what this is it's pretty much show and tell. This happens to be a thrust bearing, and I did turn a collar, and this right here is a part, and also is this one, a part off of a 92 side cover. And I did turn it out a little bit inside, turn it to length with a taper to use as a tool. It was damaged, it wouldn't work no more. So, and this is part of that crankshaft that I turned. What you do is, let's do the side cover for the outboard bearing first. And this, you see how it works. That just goes in there. The collar goes on here. The bushing goes on there. The thrust washer goes on there. This washer here I just turned for support, and the other nut goes on as such. Now, I very seldom ever use any power tools in my shop, but this is one occasion where a power tool kind of helps. And I try not to get out of camera range, but you see what I'm doing? I've got a wrench on that end and a impact on the other. But okay, y'all see that? That's one outboard bearing housing for a 2-cylinder crankcase that don't have a bushing in it. That's what it looks like. This is what we used. The support ring, thrust bearing, the collar there, shop made. The slide ring, voila. There's the bushing that we just removed right there. That's what it is. That's what it looks like. That's a bad bushing right there. Now, if we you put the micrometer on that, it's 1.060. All of them will be that. Write that down. You need to know that. Now, the other measurement that's important is the length. 1 3/4 of an inch long. This is the one that I turned to size. Put all of this aside. We'll use that to reinstall it with another additional collar. This goes back into the housing with the bevel side on the inside. It does have a notch right here, which you can mill that in there, or you can file it in with the appropriate size file. This one also has the oil groove inside the bushing. Now I can't to be honest with you, I just cannot reproduce that oil ring as is. So in lieu of that, what I do is I will put this one back in the lathe. I'll set the tool to one side, and I will plow a straight groove down to where the intersection line on this one is. I'll measure that. And then I will turn a complete circle on the inside. Come back around to the groove, draw the tool, and I'll have a perfectly acceptable oil groove. We're going to do that, and then we'll install it. Back from the lathe over there, what I done is I put that in the chuck on the lathe, and then I took that tool bit. Actually, what I used was a boring bar with a little short bit on it. And I know that I needed to go from this edge, I needed to go down 1 inch. That's where that hole is at. The distance from that hole, from that surface there on that crankshaft out to that hole is 1 inch. So I knew that I needed to go down in there 1 inch. So that's what I set my measurements on the lathe over there at. So what I've done is come over, made a groove about the same depth as the one would have been in a new bushing, and I went straight down and I ground the bit to where it would cut going or this way. So once I got right there, then I just made a circle with a little pressure on the cross slide as I went around, which produced a half of a screw thread in yonder, exactly in line with that straight mark. Then I came over here, and opposite of this opening, I filed. I didn't set the milling machine up. I had a file that was the correct size, so I did file that gap to match this one straight across from the output of that groove over there. Mine are identical to it. I just went about it a different way. When you put it on the crankshaft, you can see it's a real nice fit. Now this will change when I install it in the housing. It'll shrink it. That's nice. So in order to install that, I made this tool here to install it, and that's part of an old crankshaft cutaway, so I would have that radius there that fits that radius right yonder. To make it a little bit better to see, if I run right down yonder, that's where the gap is. And also on the back side of here, I marked where the gap should be on this one. And I don't think that's the same on all of them. I don't think there's a certain place that has to be, because you can put. And I just did that, installed several of these and looked in the side yonder to see where that gap was at, and none of them came out the same. And now I like to use something in this bore right here. Just whatever happens to be, I think I want to use that day. Today I'm going to use some of this. This is that there Gasola gasket sealer. That's some good stuff, and it's got Teflon in it. Occasionally I'll use high pressure grease, or just oil, just whatever strikes me that day. So I'm not just suggesting anything in particular for you to use, but I do think you should use something, not pull it in there dry. But this goes up on the tool with the bevel right yonder. The bevel being on the inside, that would go right like that right there. And that's just all thread comes through there. This is the other bushing that I turned that fits in that housing right there to center up the bolt. And there's a little collar there to center up that thrust. A washer, another washer, and a bolt, a nut. Now, all we're doing is pulling. When we tighten up this bolt here, it just pulls that up to that, and when this bottoms out against that housing, that's the correct depth.